Hello everyone. Karuna ma'am is going to speak on pin description of 8086 microprocessor. In the middle of her lecture, she will be using Telugu language on public demand. While you are hearing the lecture, please take down the important points. It may be useful while you are referring your textbook as a reference points. Thank you. Here is Karuna ma'am.
Hello everyone, welcome to my channel. This is Karuna teaching the course Microprocessors and Microcontrollers. In this video, we are concentrating on pin description of 8086 microprocessor. Let us see. This is the pin diagram of 8086 microprocessor. See, this is the physical structure of 8086 microprocessor. This is 40 pin tip chip. It uses 5 volts DC power supply for its operation. So it consists 40 pins. One side 20 pins are available, other side other 20 pins are available. Some of the pins are operated in time multiplexed mode. Let us see. Here microprocessor is having 16 data lines and 20 address lines. AD0 to AD15 means pin number 2 to 16 and pin number 39. These are time multiplexer signals because address lines are multiplexed with data lines on timing basis. Let us see one by one. AD0 to AD15 pin 2 to 16 and one more pin is available at pin number 39. These pins are AD0 to AD15. We can say these lines are address data multiplexed lines. To reduce the number of lines inside the IC, the pins are like this. During T1, here machine cycle consists 4 time periods, T1, T2, T3, T4, assume like that. Okay, during T1, these lines will carry lower order 16 bits because 20 address lines are there. So out of 20 lower order 16 bits, address bits are transferred through these lines during T1. In remaining clock cycles, data will be transferred. Timing diagrams for read and write operations. In case of read operation, see here T1, T2, T3, wait. These are the clock cycles. During T1, this address and data multiplexer bus will transfer A0 to A15 lines. During the remaining clock cycles T2, T3, TW, the same bus will carry data bits. Likewise, multiplexed lines will carry address, data, bits on timing basis. So that is about AD0 to AD15. Coming to A16, 17, 18, 19. So out of 20 address bits, 4 higher order 4 address bits are multiplexed with the status bits. Those are S3, S4, S5, S6. During the time T1, these lines will carry higher order 4-bit address bits. In remaining cycles, they carry status signals. Here S6 always low. Coming to S3, S4, S5. S5 is used as interrupt flag. Or we can say S5, the status S5 gives the current setting of interrupt flag. Coming to S3 and S4, these are used to select the segment out of 4 segments. Here memory, later classes we will discuss about the memory segmentation. This memory divided into 4 segments: extra segment, stack segment, core segment, data segment. Whenever these two bits S3 and S4 bits are 0, 0, extra segment will be selected. 0, 1 stack segment, 1, 0 out segment, 1, 1 data segment will be selected. Next, coming to the bus high enable or status flag S7 available on pin number 34. So this stands for bus high enable. Here bar indicates active low signal. See, all of you remember bar undi kada, aa signal unte aa signals anni kuda active low signal means that signal will be active when 0. So like that you have to remember. So we can say bus high enable is active low signal. This signal decides whether the data bus will carry 16-bit data or 8-bit data in conjunction with the A0 signal. So bus high enable and A0, if these two pins are 0, 0, that indicates whole word is transferred. 0, 1, that indicates upper byte from or to odd address, because here memory divided into odd memory and even memory, which indicates the data transfer to or from even and odd memory. 1, 0 lower byte from or to even address. 1, 1 no action. S7 always high. So during one clock cycle, bus high enable will be carried out. Remaining clock cycles S7 will be carried out. Next, coming to read signal, that is available on pin 32, which is active low signal. It indicates that read operation is performed by the microprocessor from memory or I/O devices. Next, clock signal. This is available on pin number 19. Signal at this pin provides the basic timing for processor operations. Next, coming to the reset signal available at pin 21. Whenever this pin is enabled, then it resets the processor and other devices connected to the system by immediately terminating the reset task. Means whenever a processor enters into reset mode, this signal will become high. VCC available at 40th pin. That pin is connected to the plus 5 volts power supply, and ground available at pin 1 and pin 20. These two pins acts as a ground signals. Next, let us see test pin. This is active low signal. It is used in conjunction with the wait instruction. ఇక్కడ నేను బార్ యూజ్ చేయలేదు కానీ టెస్ట్ కి బార్ ఉంది. That's what we can say this is active low signal. Whenever this signal is low, then signal will be activated. Okay, so this signal is used to test the status of math coprocessor 8087. That is in case of multi-processor environment. Okay, next INTR, interrupt request, available at pin number 18. Okay, so this stands for interrupt request signal, which is a level triggered interrupt. Later we will discuss about level trigger. During high or during low, we can treat it as a level triggered. Okay, the signal is active high to determine if the processor considers this as an interrupt or not. So if any external device wants to interrupt the microprocessor, then it sends the request to the processor through this pin. Next, this is maskable interrupt. Maskable ante ఇది జీరో చేయొచ్చు అన్నది. ప్రాసెసర్కి ఇంట్రెస్ట్ ఉంటే ఆ పర్టికులర్ ఇంటరప్ట్ ని రిక్వెస్ట్ ని యాక్సెప్ట్ చేస్తుంది, లేదంటే యాక్సెప్ట్ చేయదు. దట్స్ వాట్ వీ కెన్ సే మాస్కబుల్. NMI, non-maskable interrupt. This is edge triggered interrupt. It is detected during the clock cycle from low to high or high to low. That's what edge triggered interrupt we can say. These interrupts are basically uncontrollable interrupts generated inside the processor. ఈ నాన్ మాస్కబుల్ అంటే దీన్ని జీరో చేయలేం. వెరీ వెరీ ఇంపార్టెంట్ టాస్క్ అయితేనే ఆ పర్టికులర్ ఇంపార్టెంట్ టాస్క్ ని ప్రాసెసర్కి ఈ పిన్ నుంచి కనెక్ట్ చేస్తాం. So whenever interrupt occurs through this pin, processor immediately stops its execution and jump to the particular requested interrupt or jump to the IO device based on the interrupt request. Okay, so that is about non-maskable interrupt and interrupt request. Both are active high signals. Ready pin. Here ready pin is available on 22 pin. Okay, this signal is used by the peripherals, means memory or IO devices, to indicate whether the peripheral device is ready to transmit data or not. Okay, now let us move on to this min or maximum mode. Very important. So min or max mode, when this pin is connected to high, processor will operate in minimum mode. When this pin is connected to low, then processor will be operated in maximum mode. So hence we can say this pin shows whether the processor is operating in minimum mode or maximum mode. So whenever low means min or max pin is connected to 0, it operates in maximum mode, that means multiprocessor environment. If it connects to plus 5 volts power supply, then it comes under minimum mode operation, named as single processor in that environment. Okay, so based on this connection, these lines will be activated in maximum mode or minimum mode. The same lines are used for minimum mode and maximum mode. Whenever this pin is connected to plus 5 volts, these signals will be acted as minimum mode signals. Whenever this min or maximum pin connected to 0 volts, these pins from 31 to 24 will be acted as maximum mode signals. Let us see one by one. In minimum mode, these pins are available. Okay, so for example, INTA available at 24. Okay, this is interrupt acknowledge pin. Whenever an interrupt request is generated, then the microprocessor generates acknowledgement signal as a response to that interrupt. Okay, other external devices ఏమైనా interrupt request ని ప్రాసెసర్ కి సెండ్ చేస్తే, ఏ ప్రాసెసర్ కనుక రెడీగా ఉంది అనుకుంటే acknowledgement signal ని other devices కి ప్రాసెసర్ సెండ్ చేస్తుంది. Next, coming to the ALE, address/enable. Active high signal, INTA is active low signal. So active high signal address/enable, it is generated each time the processor begins any operation. And also it indicates the availability of valid address on the address data lines. Processor ఏ ఆపరేషన్ అన్న స్టార్ట్ చేసే ముందు processor issues ALE signal first, which is active high signal. That indicates the transmission of address. Okay, so next, hold acknowledgement signal. We have already discussed about these two signals in CAO subject. Okay, so hold signal, it is coming from DMA. Okay, so when DMA controller needs a address data bus, it sends request to the CPU through this pin. On receiving this signal, if processor ready to issue the bus, then it sends the acknowledgement signal to the DMA controller through this pin, hold acknowledgement pin, available at 30. Okay, next, data enable stands for data enable. It is active low signal used to enable trans receiver. It is a device used to separate data from the address data bus. Next, coming to the data transmit or receive. This is available on pin number 27, stands for data transmit or receive signal, which decides the direction of data flow through the trans receiver. When it is high, data is transmitted out, otherwise data will be received. ఓకే. సో ఈ సిగ్నల్ కనుక మనకి హై అని చూపిస్తే డేటా ట్రాన్స్మిట్ అవుతుంది అని మనకు అర్థం అవ్వాలి. ఈ సిగ్నల్ కనుక లో చూపిస్తుందంటే ఓకే, మైక్రోప్రాసెసర్ is performing a read operation. Like that we can understand the signal on this pin. Next, memory or IO pin available at pin number 28. This signal is used to distinguish between memory and IO operations. When it is high, it indicates memory operation, and when it is low, that indicates IO operation. Write operation. This is also active low signal, stands for write signal. It is used to write the data into the memory or the output device depending upon the status of M or IO signal based on this pin number 28. That is memory or IO status. Next, coming to the maximum mode pins, those are QS1, QS0, S0, S1 bar, S2 bar, lock signal, request or grant 0, request or grant 1. See, let us see first QS0, QS1. These are used to produce the status of instruction queue like this. QS0, QS1. If both signals are 0, 0, that indicates no operation. 0, 1, first byte of opcode from the queue. 1, 0, that indicates queue is empty. Both are 1, 1, subsequent byte from the queue. Okay, likewise, queue status will be indicated with these pins. Next, S0, S1, S2. So these signals are connected between microprocessor and 8288 bus controller in case of multiprocessor environment to generate memory and IO access control signals. Let us see. These signals are active low signals. These signals are 0, 0s. It indicates interrupt acknowledge. 0, 0, 1, read data from IO port. 0, 1, 0, write data to IO port. 0, 1, 1, halt. 1, 0, 0, fetch the opcode. 1, 0, 1, read operation is performed from memory. 1, 1, 0, that indicates write operation is performed to memory. All ones passive state. Likewise, status signals indicates about IO and memory operations, read and write operations. Lock signal. This is active low signal, indicates to the other process not to ask the CPU to leave the system bus. Means lock the bus. It is activated using the lock prefix on any instruction. Next, coming to request grant signals. These are also discussed in CAO subject in case of DMA. These are the request grant signals used by the external devices like DMA controllers. These pins used for requesting the CPU to release the system bus. When the signal is received by the CPU, then it sends acknowledgement. That is request grant signal. So request or grant 0 has a highest priority than request grant 1. So on request of bus, processor will grant the bus to the processor. So ఇక్కడ ఏంటంటే request signal is coming from DMA, grant signal is coming from processor. So this is how signals representations of 8086 microprocessor. These are the read cycle and write cycles. For example, let us see time multiplexed lines means address or data. During T1, these group of lines carries address bits. Other timing cycles, these group of lines carry data bits. ALE signal, issues the ALE signal. Before going to start any operation, initially processor issues ALE signal, which is active high signal. Okay, so these are about the status signals S0 to S2 and address status for upper or higher order bits A16 to A19 are carried out by this bus during time T1. In other timing cycles, status lines S3 and S7 are transferred. Okay. Likewise, signals are carried out with the help of all these pins. Thank you. We will discuss about architecture of 8086 microprocessor in next video. Thank you.